Now let us see what is happening to the barred galaxy. In a barred galaxy, it is the system is the formation of the system is the same with respect to the massive inner ring, the structure is the same, and even the spiral arms also the structure is the same. What is peculiar about the barred galaxy, as the name itself suggests, that there are two bands of stars and they are thickly populated on either side of the galaxy or on either side of the inner ring, and where the inner intermediate ring meets the spiral arms, you have Ansae forming on either sides again. So we will study how these galaxies are formed. To begin with, let us see the play of forces, and again just the way we studied in spiral galaxy, S1 being a holding pressure and a holding force is not imparting any kinetic energy. So we will not discuss about S1, effect of S1 on the galaxy formation. So let us limit ourselves to S2 and S3. As we had said, in the inner ring, as you move away from the center of the galaxy, just like in a spiral galaxy, non-barred spiral galaxy, the cumulative mass corresponding to that particular circumference is increasing, and hence S3, which is directly dependent on the mass of the system it is acting on, is also increasing. So you have all of these stars moving like as though they are one single block. And again, play of forces between S3 and S2 in spiral arms would lead to all these stars falling back, because the combined effect of S3 and S2 is not able to push the stars beyond the basic speed of the stars on the edge of the perimeter. But what is different is the intermediate ring that we have shown between A and B. A is where the massive inner ring ends, B is where the spiral arms start. Now between A and B, S3 and S2 play out. But let us see, when you move away from the galaxy, you would see that the cumulative mass of the stars in that particular circumference is same. 4 here, there is 4 on the other side, so 8, 8, 8, 8. So that means the mass remaining constant, the S3 also should have remained constant, and when you have a constant speed, as you move away, these stars should have fallen back, just the way you see in the spiral arms. But it does not happen. So what is making these stars move faster than normally as seen in the spiral arms? So there are two factors which are helping us or helping these stars. As you have seen, at the junction B between the spiral arm and the intermediate ring, you will see that there is densely packed stars, and this would be generating a secondary supermassive mass, and this secondary supermassive mass acts on all these masses. So this is like, for S2 you need a primary mass and a secondary mass. This massive mass acts like a primary mass, and all these masses, the stars in the intermediate ring, act like a secondary mass. So as you move away from the galaxy, you will see that as you are moving towards nearer the Ansae. So when you are moving near this Ansae, obviously the effect of this Ansae keeps increasing. That is one of the factors which is stopping these stars from falling back. Another factor that is stopping it from falling back is the S3 itself. As we had seen, this has created a huge accumulation of stars which is densely packed, much densely packed than what you see here. This in turn would lead to, as we see in Ansae formation, there would be a backlash of this accumulation, and hence as you move towards this, the density also decreases. So when you are moving from here to here, as you approach the Ansae, this mass, the density of stars is increasing. Since the density of stars is increasing, cumulative mass of these stars in that particular circumference is also increasing. That would lead to an increasing S3. So, when you have an increasing S3 and an increasing S2, obviously the speed would be increasing, and that speed is the one which allows the stars in this to move along as though they are a part of the massive inner ring. This is the play of forces between S2 and S3. But let us now study why do these bars and Ansae form in the first place. So, there are three factors affecting it. One is the star density. So, in the inner ring we know that they are densely packed stars. In the spiral arms you have sparsely populated stars. What is happening here in the intermediate ring, though it now looks like densely packed, that is after formation. Imagine you turn the clock a few million or billion years ago. To begin with, possibly all these stars were not packed like this. These were distributed all around this intermediate ring. So, you can imagine all these stars which are now packed here would be distributed along this, and you can imagine those density would not be as much as you see here. It would be intermediate density. And it is not just that, and they would be unevenly distributed. Let us see. And the next factor is the gyroscopic forces. Any rotating disk, any rotating mass in the universe would always want to be, it seeks balance. If there is any imbalance in the system, it tries to remove those imbalances, and those forces are called as gyroscopic forces. And obviously, since galaxy is also a rotating disk, the gyroscopic forces also act on every section of it. But the effect of that gyroscopic forces is not uniform everywhere. When it comes to massive inner ring, you see that they are densely packed. There is an inbuilt balance in the system. So, the effect of gyroscopic forces on the massive inner ring is minimal, and on the spiral arms, the fact that they are on the edge, they can seek easily the balance. Even if there is any imbalance, it can easily seek, because it has the freedom to move. But what is happening in the intermediate area, all these rings are boxed in on either side, on the outside by the barrier created by the spiral arms and inside by the massive inner ring. So, and these stars to begin with, not in this position where they are now distributed in the intermediate ring, they are unevenly distributed, and that uneven distribution would lead to an imbalance in the system. So, a rotating disk there would be a back and forth rocking, and that back and forth rocking keeps on happening millions and billions of years. So, let us imagine what would happen when a disk is rocking back and forth. Obviously, the gyroscopic forces would create that rocking back and forth would have an axis. Whenever it is rocking back and forth, there would be a major axis across which it is rocking back and forth. So, the gyroscopic forces would align to begin with a line of stars, which is where the imbalance is the least, minimum. Not that these stars would be static, they would be moving all along. It is just that these stars align themselves along this major axis where the imbalance is the least. And then, as we said, over a period of millions of years, all other intermediate stars would be acted upon by the gyroscopic forces in such a way that they have to align themselves along this major axis on either side of the inner ring. And when that happens over a period of time, all these stars, either they have to choose a side between here and there and then achieve a balance. And when that is happening, you would see the formation of a band of stars which is thickly populated, which we call it as bar. That is about the formation of bars. But how do Ansae form? You can see here the Ansae are as though there is a stampede happening here. So, let us study how that comes into picture. The periphery B that I have shown Let us assume that the spiral arms they have not started forming here. Let us assume they started forming somewhere here. Then all these stars would be evenly distributed till here, as though this rectangle. But unfortunately, for the intermediate ring, the spiral arms, instead of starting here, they would be starting here. This in a way would create a barrier for all these intermediate rings, the stars in the intermediate ring, which are trying to align across this axis where the imbalance is least. They will be forced to accommodate in this area itself, because the barrier has closed, the door has closed, so there will be a stampede, and that stampede is what we see as Ansae. That is how bars and Ansae are formed.